Welcome back to the tutorial course on Android app development. In the previous lectures, we added the location to the Add Location screen using two different methods. Using the first method, we added the location using the GPS. Using the second method, we added the location manually. We will now implement the main functionality of fetching weather details for a selected location. On the next slide, we will learn part 3 of application development. In the previous lectures, we used the OpenWeatherMap API for fetching weather details. In this lecture, we will discuss the following: OpenWeatherMap API, or OWM API, web services, and fetching weather details using OWM API. OpenWeatherMap is an online service that provides a free API for weather data, including current weather data, forecasts, and historical data, to the developers of web services and mobile applications. It gives different weather information such as temperature, pressure, humidity, wind, and weather description. In the case of data sources, it utilizes meteorological broadcast services, raw data from airport weather stations, raw data from radar stations, and raw data from other official weather stations. The data received is processed by the OpenWeatherMap API, which attempts to generate accurate online weather forecast data and weather maps, such as those for clouds or precipitation. Beyond that, the service focuses on the social aspect by involving owners of weather stations to connect them to the service to enhance the accuracy of weather data. The ideology is inspired by OpenStreetMap and Wikipedia that make the information freely available to everyone. OpenWeatherMap uses OpenStreetMap for displaying weather maps. On the next slide, we will learn about the OpenWeatherMap API. We will now understand the OpenWeatherMap API implementation. First, we need to access the OpenWeatherMap's website and familiarize ourselves with the information available. The following website has different weather information available for selected locations: http openweathermap.org. If we search for a location, we can see the weather information for that particular location. In the bottom section of the website, we can see the public weather API links. Different pieces of weather information, such as current weather data or 5-day or 3-hour forecasts, are available. Click Current Weather Data. We can get the weather information for a location by providing any of the following information: city name, city ID, geographic coordinates, zip code. We will now get the weather information by providing the city name. The information regarding weather is available in different formats, such as JSON, XML, or HTML. We will now click a link for a particular location. The weather information is available in the JSON format. The app ID of the application is displayed. If our mobile application needs an app ID, then we have to create an account on the OpenWeatherMap website. For this lecture, an account has already been created on the website. We will now sign into the website with our credentials. After successful sign-in, the API key is displayed. Now, we can get the weather information using the new API key. We will now copy the API link to a new tab and add the API key. The weather information is now available. If we change the city name, we will get the weather data for the respective city. Now, we will integrate this OWM API into our weather application. On the next slide, we will learn about the weather screen. Open Android Studio and add the location fragment. We have already manually added the location names to the list. In addition, we have fetched the current location using the GPS. We will now add that current location name to the location array. We are showing different pieces of weather information, such as current weather data for today, which is the weather data for the next 24 hours, and weather data for the next 5 days. We will create a tabbed activity called Weather Activity. Then, we will extend the class from the app_compat activity for the backward compatibility. When we select any location from the Add Location screen, we will get the event in the location list adapter. We will create an intent in that location name, click Listener, and pass the location name to the weather screen. We will get the location name in weather activity and store it in a variable. Now, we will call the OpenWeatherMap API to get the weather details for the selected location. We will use the web services to get the weather details. On the next slide, we will learn about web services. A web service is a piece of software that makes itself available over the internet and uses a standardized XML messaging system. XML is used to encode all communications to a web service. For example, a client invokes a web service by sending an XML message and then waits for a corresponding XML response. Web services are client and server applications that communicate over the World Wide Web's Hypertext Transfer Protocol. As described by the World Wide Web Consortium, web services provide a standard means of interoperating between software applications running on a variety of platforms and frameworks. In our OpenWeatherMap API, the output responses are available in the following different formats. JSON. JSON is a lightweight data interchange format. It is based on a subset of the JavaScript programming language. It is the syntax for storing and exchanging data and can be considered an alternative to XML. Extensible Markup Language, or XML. XML was designed to store and transport data. It was designed to be both human and machine readable. Hypertext Markup Language, or HTML. HTML is a markup language for describing web documents or pages. A markup language is a set of markup tags. HTML documents are described by HTML tags. Each HTML tag describes a different document content. On the next slide, we will learn about async task. We will use async task for the service call. However, before we use async task, we need to know about async task and its uses in Android applications. Async task is an abstract Android class that helps Android applications to handle the main UI thread in an efficient way. The async task class allows long-lasting tasks or background operations to run and shows the result on the UI thread without affecting the main UI thread. In Android applications, there can be potentially slow-running operations or tasks, such as accessing resources like MP3, JavaScript Object Notation or JSON, or images from the internet. Other slow operations, such as database operations, web service calls, and complex logic that may take a long time to execute in an Android application, should be made to run asynchronously. We will now call the Weather API in an asynchronous manner. The main methods of async task are onPreExecute. This method is invoked before the task is executed, ideally before the doInBackground method. This method is normally used to set up a task such as showing progress bar in the UI. DoInBackground. Code running for long duration should be put in the background using the doInBackground method. OnProgressUpdate. This method can be used to display any form of progress in the user interface. OnPostExecute. This method is invoked after background computation completes processing in the doInBackground method. The result of the doInBackground method is passed to this method. We will get the final result in PostExecute method. On the next slide, we will learn about weather details. We will use the weather activity and create a new class called WeatherTask by extending async task for the WeatherMap web service call. We will need to implement all the methods. We will use the HTTP client for service call. To use the HTTP client, we need to create an HTTP client object. We need to create an HTTP post object with the incoming parameter and execute that post method to get the HTTP response. From the response, we need to get the HTTP entity object. And convert it to a string value using entity utils. Then we need to return this value from this method, and the response string is available in the post execute method. We then need to copy the response from the OWM site to a JSON link for proper formatting. Normally, the JSON response contains JSON objects, JSON arrays, and etc. The JSON object is presented with curly braces, and the JSON array is presented with square braces. Our response contains JSON objects and JSON arrays. This is a JSON object. This is a JSON array. In the response, temperature, pressure, humidity, and wind speed are available. From the root JSON object, take the JSON object as the main key. From that JSON object, take the temperature value with the temp key. Similarly, we can also access humidity and other parameters. Log all the parameters inside this method. In the response, temperature, pressure, humidity, and wind speed are available. From the root JSON object, take the JSON object as the main key. From that JSON object, take the temperature value with the temp key. Similarly, we can also access humidity and other parameters. Log all the parameters inside this method. Now, we need to add the selected city name that we received from the location screen. We then need to call the execute method of async task. Finally, we run the application. We will need to select a city to fetch the weather details. If we check the logs, we will find different pieces of weather information, such as temperature, humidity, pressure, wind speed, etc. This is the current weather data for the selected location. We can populate these values to our application user interface in the next section. This brings us to the end of our discussion on the Open Weather Map API, OWM API implementation, and web services using async task.